So we have y double prime plus x squared, x squared times y prime plus x times y equals 0. Now these problems take a really long time. They're super tedious, and so bear with me. So take note that this is a second order linear differential equation, and next to our y prime and our y, we have a variable coefficient, not a number. So because we have a variable coefficient, most linear higher order differential equations with variable coefficients cannot be solved in terms of elementary functions. So this is why we use our knowledge of power series to solve this differential equation. So the first thing I'm going to do is I'm going to write my y prime, and my y double prime. Okay? And my power series is okay? So this is my power series for y. Now I need to take the derivative of this, the first derivative and the second derivative. So let's take the first derivative of this. Well, it's the same idea of taking the derivative of this. I'm going to bring the 3 in front, so 3 times 5, x to the 3 minus 1. Same idea here. Okay, so I'm going to bring the n to the front, n times a sub n, x to the n minus 1. And then now this is a 1. Okay, so now let's take a derivative again. So we're going to bring n minus 1 to the front, n minus 1 to the front, times n, a sub n, x to the n minus 2. Okay, so that's our first step, just writing that all out. Okay. Step 2. Step 2, we want to substitute. Okay, so we want to substitute these into this differential equation. So y double prime is now plus x squared times y prime plus x times, so we just set it up right now. And remember before I mentioned about the variable coefficients, so we have a variable coefficient here and here. We need to multiply this guy in. So to do that, for example, if we had x squared times x to the third is just x to the 2 plus 3, which is x to the fifth, right? So x squared times x to the n minus 1 is just going to give us x to the n plus 1, right? Because it's 2 plus n minus 1, which is just n plus 1. So this multiplied by this, it gives us sorry. And then, oh, I forgot the x to the n over here, right? Because I have to substitute this in. Okay, so x times x to the n is, well, this is just to the first, so it's n plus 1. Okay, I'm just going to rewrite this. Okay, so step 3, we now want our powers of x to match. So powers So our goal is to make them all x to the nth power. So this is n minus 2, this is n plus 1, this is n plus 1. We need to make them all just to the n. So to do that, we're going to basically just add and subtract. So n minus 2, to make this just n, we have to add it by 2, right? So then this goes away and just becomes n. So basically, we have to add this by 2. So we're bumping this up by 2. And in turn, we have to add everything inside here by 2. So this all gets added by 2. Now, in turn, on the same token, we have to subtract this by 2. Okay? So basically, the idea here is if I had a summation x to the n, let's say an n equals some number, if I want to bump this n or add this n by, let's say, for example, 3, in the same token, I have to bring this down by 3. I have to subtract this by 3. And vice versa. Let's say at n equals some number, x to the n. If I bring this down by, let's say, 2, in the same token, I have to bring this up by 2. So it's opposite. Okay? So now I'm going to bring this down by 2. So this is going to be, get black. Yep. So this is going to be n equals 0 to infinity of n minus 2 plus 2, n minus 1 plus 2 is just n plus 1, and n plus 2 is just n plus 2, a sub n plus 2, x to the n. Okay, so that's done. So over here we have to do the same thing. So this is n plus 1. Now to get this just n, we have to subtract by 1. So then these cancel out, leaving us with n. So we're going to bring this down by 1. And in turn, we have to bring this down by 1 and this n down by 1. So everything in here gets subtracted by 1. And in the same token, we have to bring this up by 1. Okay? Okay. So then we have plus. Alright, same idea here. We're going to bring this down by 1. So we're subtracting this by 1. So everything in here gets subtracted by 1. So this n also gets subtracted by 1. And in the same token, we have to bring this up by 1 to keep it consistent. Alright, so we got our powers to match. This is x to the n, this is x to the n, and this is x to the n. Now we want our indices to match. So our fourth step, I'll write over here. Okay, we want our indices to match. Now look, we have n equals 0 as one of our indices, n equals 2, and n equals 1. So we look at our highest indice, which is n equals 2. So we try to make all the other series into n equals 2, our highest indice. So let's do that. This is n equals 0. We're going to put in 0 wherever we see an n. So 0 plus 1 is just 1. 0 plus 2 is just 2. A sub n plus 2, well, we're going to put a 0 wherever we see an n, so it's a sub 0 plus 2, which is just a sub 2, x to the 0. Okay? And now we put in 0, this becomes 1, so let's put in 1. 1 plus 1 is 2. 1 plus 2 is 3. A sub 1 plus 2 is 3, x to the first. Okay. Now this becomes 2, which is exactly what we wanted, so we just write it out. Okay, so then we write it out. Alright, so then this is done. This one already is at n equals 2, so let's just write that out. Okay. Plus, well, this is at n equals 1, so let's put in 1. So a sub 1 minus 1 is just a sub 0 of x to the first. Okay. Plus, now this is at 2. Alright. Alright, so we have one big mess. Now let's just clean it up. So this is just going to be 2 a sub 2. Because 1 times 2 is just 2. A sub 2 x to the 0 is just 1. So 2 times 3 is 6. And then x to the first is just x. I'm going to erase that. Okay. Now our fifth step is we want to equate coefficients. Okay. So you have 2 a sub 2. 2a sub 2, we're going to set it equal to 0, right? Because there's a 0 on the other side. So 2 times a sub 2 equals 0. So a sub 2 equals 0. Okay? So we did that. Now, so basically we're looking at everything that doesn't have a summation next to it. So this doesn't have summation, this, and this. So these were the things that don't have summations next to it. Now, these get added together, the 6a sub 3 times x plus the a sub 0 times x, because they both have an x. And this is 6a sub 3 times x plus a sub 0 times x equals 0. Now, why it's equals 0, well, think of it. Equals 0 plus 0x plus 0x squared. This is just all 0. So you're just equating coefficients. So let me erase that. Okay, and we don't need the x. I'm just putting it there just to show you that these two get added together because they both have an x to the first power. Okay, so let's solve this for a sub 3. Okay, so a sub 3 equals negative a sub 0 over 6. Okay, so we dealt with this and this. So let's just rewrite this. So we have the summation of n equals 2 to infinity of n plus 1 . Okay, so then now take note that we have a lot of similarities in here. So we have this has this is a summation n equals 2, this one, and this one. So we could factor that out. We can also factor out an x to the n because they all have an x to the n. So our sixth step, we could write factor out the summation n equals whatever number you have to the x to the n. So we're going to factor this out. And then in here, we're going to get our recurrence relation. I did not spell that right. Recurrence relation. Okay? So we're going to factor out. In this case, we're factoring out so what's left in here, we have an n plus 1, n plus 2, times a sub n plus 2, plus n minus 1 times a sub n minus 1, x, oh, we already factored that out, plus a sub n minus 1. This is all equals to 0. Okay, so what's in here is called our recurrence relation, and we're going to use this to solve. So looking at this, we can distribute this a sub n in here, n minus 1 in here, right? So we'll get n plus 1, n plus 2, a sub n plus 2 plus n times a sub n minus 1 minus a sub n minus 1 plus a sub n minus 1 equals 0. These cancel out because this is a plus a sub n minus 1 and this is a minus a sub n minus 1. So then this becomes okay. And now we're going to solve, now we're going to solve for our highest sub, a sub. So this is a sub n plus 2. We're going to solve for that. So we're going to bring everything to the other side. So this will be a sub n plus 2 equals negative n times a sub n minus 1 over n plus 1 times n plus 2. Okay? And then we're going to input values n equals 1, 2, 3, 4, 5, dot, 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 dot. Okay, so we're halfway there. I know these problems are super long, and I don't even have room. Let me erase some stuff. I apologize about how long and I'm taking to solve this. So let's go to the side. If I have room. Okay. All right, so now we're going to put in n equals 1. We're going to put in n equals 1. We're going to input n equals 2, n equals 3, n equals 4, and n equals 5. We'll also put n equals 6. And then you're going to input these values, and then you're going to get your answer. So I'm just going to erase some stuff from the top. Okay, so we had before okay, and then remember we solved for a sub 2 already, and we got 0, and we already solved for a sub 3, and we got negative a sub o over 6. Okay, so we already had that. Now let's put in values. So n equals 1. So n equals 1 is going to be, well, so wherever we see an n, we're going to put in a 1. So this is going to be a sub 3 equals negative 1 over 2 times 3, a sub 0. Well, and then that's going to give us negative 1 over 6, a sub 0. Okay. Now n equals 2 is a sub, well, 2 plus 2 is 4, is 4, negative 2. So I'm just putting in a 2 wherever I see an n in here. So I'm using this. Okay, 2, 4, 3 times 4, sorry. 3 times 4, a sub 1 equals negative 1 over 6, a sub 1. Okay, n equals 3. This is a sub 5 equals which this just equals 0 because a sub 2, remember, from before we said it's 0. So this is basically times 0, which gives us 0. So let's do n equals 4. So that's a sub 6. I'm just going to quickly write this out. You probably get the point by now. 5 times 6. I'm sorry, this is taking a long time. So this is going to be negative 2 over 15 times negative 1 over 6 a sub times a sub 0, which is just 1 over 45 a sub 0. So a sub 4, remember from before, a sub 4, we already solved for a sub 4 right here. So a sub 4 equals negative 1 over 6 a sub 1, right? So a sub 4 is really, let's write this out, 6 times 7, is really just multiply this by negative 1 over 6 a sub 1, right? Just like before, this a sub 3 right here, we already solved for it. A sub 3 is really negative 1 over 6 a sub 0. So that's where this a sub 0 came from. Or, well, this negative 1 over 6 a sub 0. So same idea here. So negative 5 over 6 times 7 times negative 1 over 6 a sub 1. This, remember, this is like saying a sub 4 right here. A sub 4 equals this. Okay, and then this will equal 5 over, okay, all right, so we solve for that. All right, thankfully I did this part already, so n equals 6. Let's just do one more. So that's a sub 8. Oh, it's important to see this. I'm getting it from here. A sub 8, negative 6, 7 times 8, 8 sub 5, 0. So, well, a sub 5, we already solved for that. A sub 5 is just 0, so this is multiplied by 0, which that's why we got the 0 here, because anything times 0 is just 0. So then, remember from our knowledge of power series, basically, we got all of that. So a power series centered at 0 is just an infinite series of the form a sub 0 plus a sub 1 times x plus a sub 2 times x squared plus a sub 3 times x to the third plus a sub 4 times x to the fourth plus a sub 5th times x to the fifth, and so on. So remember this from Calc 2. This is just our power series. So we have a lot of these values. We have a sub 0, right? Where is a sub 0? Oh, we don't have a sub 0. I'm sorry. Okay, so I meant to say we have a sub 1. We have, do we have a sub 1? Oh, no, we don't have a sub 1. Oh, but that's fine, that's fine. Oh, it's supposed to be like that. I'm so sorry. So these two, all right, so we don't have these two, and that's fine. That's exactly what we wanted. This is perfect. I'm sorry. So we have a sub 2, we have a sub 3, we have a sub 4, we have a sub 5, we have a sub 6, we have a sub 7. So we have an a sub 6. I can write this out. A sub 6, x to the 6, plus, once again, no more room, a sub 7, x to the 7, plus, etc. So we're going to get two solutions. I need this, so, okay. So I'm going to move to the side. Okay, so we're going to use that and just substitute in. So we don't have an a sub 0, that's fine, that's exactly what we wanted. So we don't have this a sub 0 plus a sub 1 times x. Okay, so we know we're going to have two solutions. So plus, okay, so what's a sub 2? Let's look for a sub 2. A sub 2 is just 0, right? We have it here. So we're going to plug in 0 for here. So this is just going to be 0. So this is going to be plus 0. Well, times x squared, but 0 times x squared is just 0. Plus, now we want a sub 3. A sub 3. We're looking for a sub 3. So we have a sub 3. We said a sub 3 is negative 1 over 6 times a sub 0. Okay, now we need a sub 4. So we did this. Now we're looking for a sub 4. So a sub 4 is right here, negative 1 over 6 times a sub 1. So okay, now we're looking, let's see, from down here. Okay, so we did this. Now we already did this. Now let's look for the a sub 5. Well, what's a sub 5? A sub 5 is just 0, right? So a sub 5 equals 0. So it's just going to be plus 0, or well, plus 0 times x to the 5th, but that's just 0. Okay, so what's a sub now? We did that. Now we're at a sub 6. Well, let's plug in a sub 6. A sub 6 from here, a sub 6 equals 1 over 45 a sub 0 plus 1 over 45 a sub 0 x to the 6th, right? Yep, x to the 6th. Okay, so we did that. So now we have to find a sub 7 and then multiply by x to the 7th. So a sub 7 is 5 over 252 times a sub 1. So plus 5 over 252 times a sub 1. And we want to multiply it by x to the 7th. So we did that. Plus x to the 7th, oh sorry, times x to the 7th, and so on. Okay, now we're going to split this up into 2. So we're going to use this. So we're going to have a sub 0 times and this is y equals a sub 0 and a sub 1. Okay, so we're using this. We have a sub 1. So a sub 0, when we take it out, we got a 1 plus this plus, oh, minus, really. One over 6, x to the 3rd. What else has an a sub 0? This also has an a sub 0, so this is going to be plus 1 over 45, x to the 6th. Okay, and what else? Alright, now a sub 1. Well, this has an a sub 1. This has an a sub 1, but it's next to an x, so we're going to put the x here. What else has an a sub 1? This has an a sub 1. So this is going to be minus 1 over 6, x to the 4th. And over here, plus 500 over 252, the x to the 7th, plus dot 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 dot. Okay. And then we're just going to write out our two solutions as Okay, so that's how we do it. I'm really sorry if I confused you, or, I know how difficult these problems can be, and they're super long and tedious. So basically, just to quickly recap, so the first thing we did was we wrote out this. A sub n x to the n minus 2. So we wrote out this was our first step. Our second step, we substitute in these values into our differential equation. Our third step is we wanted our powers to match. So we do that by basically bumping down or bumping up, or you put this up and this goes down. So just basically adding and subtracting from before. Our fourth step was we wanted our indices to match. So we looked at our highest indice and tried to make all the series match to that. Our fifth step was we factored. We factored the summation n equals whatever number we had. In our case, we had a 2, x to the n. And then we got our recurrence relation in here. So this was our recurrence relation in here. And then, we just solved for our recurrence relation. So when you solve, so in here was our recurrence relation. I'm so sorry, I'm spelling that wrong probably. In here was our recurrence relation. And when you get your recurrence relation, you set it equal to 0, and then you solve for the highest a sub n plus whatever number. So you solve for the highest this. So in our case, we solved, when I looked from before, we solved for a sub n plus 2. So you solve for the highest this. And then, you just observe the pattern, you substitute, you factor, and you get this as your answer. So once again, I'm really sorry about how long this was and how tedious. Oh, and last thing to note, when you want your powers to match, a good goal is you want it to be x to the n. All right. So there we go. And yeah, that's it. Thank you.